can be between 3 to 4 volts with the help of copper wires. So here I told you that the movement of electrons is from the negative terminal of the cell to the positive terminal. But however, by convention, the direction of electric current is taken to be from the positive to the negative one. But how exactly is the current flowing in the circuit? Or through which material is this current flowing? Yes, it's the copper wires. Electric current is flowing through the copper wires from the positive to the negative terminal. So what can we conclude from this? We say that the copper is a conductor of electricity since it allows the electricity to flow through it. Now, instead of copper wires, what if we use pieces of threads in the circuit? Will the bulb glow in that case?
So now in this video, we had learned the copper conducting materials and its definition. And next, I will share this PPT with you also, so you can watch the whole video. So I will share the next slide. What are conductors? We all know conductors are the materials which allow the electricity to flow. Because they allow the flow of electrons from one atom to another, and this is called as conductor. The conductor's properties are: first, the property is resistance, second one is inductance, and third one is it is having the electric field inside the conductor is zero, and the charge density is also zero. The free charge also exists in the conductor. So normal surfaces, the electric field is normal to the surface conductor. So what are conducting materials? As we seen in the video, the conducting materials definition, same it is as the materials which conduct electricity due to flow of free electrons when an electricity potential difference is applied across them are known as conducting materials. So this is the proper definition of conducting materials. And the conducting materials are classified into two types. First one is low resistivity or high conductivity conducting materials, and second are high resistivity or low conductivity conducting materials. So what are low or high conductivity conducting materials? Materials which are having low resistivity or high conductivity are very useful in electrical engineering product. This type of materials are used as conductor for all kind of windings required in electrical machines. As we had seen, the windings are in fans and in such electrical gadgets, a lot of windings required. So in that windings, copper is the best material used. And they are also these materials are also used as conductor in transmission lines for distribution of electrical energy. Some low resistivity and conducting materials are silver, gold, copper, aluminium. These are four conducting materials. So what is high resistivity conducting materials? The materials which have high resistivity or low conducting materials useful in electrical engineering product. These materials are used in manufacturing of the filaments for incandescent lamp, heat elements for electrical heaters, space heaters, and electric irons. So high conductivity materials are tungsten, carbon. Tungsten is seen in every lamp. We have seen in our house. Zero or every bulb is having a tungsten. Carbon. We have seen the carbon in cells which are used in in clock cells. Mobile batteries also there is a carbon. Nichrome. Nichrome B tray B. Nichrome V or B tray C. And magnesium. Areas of application are electrical conducting and materials. So you can see here the areas of application. It is used at bimetal, and this is the flow chart of area of application. So we will move forward. Copper symbol is Cu. It is from the periodic table family 11, which is transition metal, having an atomic number 29 and relative atomic mass 63.546. Density, as you can see here, 8.96 gram per cubic per centimeter cube. Color is red. its melting point is 108.62 degrees Celsius. Boiling point is 2560 degrees Celsius. It is having electrical conductivity 58.0 to 58.9 and thermal conductivity is 3.94 WCM or per centimeter square degree Celsius. At 20 degrees Celsius it is counted. Properties of copper. It is highly electrical conductivity, high ductility, good heat conductivity, corrosion resistance, good machinability, antimicrobial properties or biofoiling resistance. As we can see now in homes, for some are using copper materials for the use for drinking waters, and some god god for some prestigious use, and it is non-magnetic. So application of coppers are power transmission lines, architectural applications, cooking utensils as used said, spark plugs, electrical wiring cables and bush bars, high conductivity wires, electrode, heat exchangers, refrigeration tubing, plumbing, water cooled copper cubicles. So next topic is aluminium. Aluminium, it is having an atomic number 13 and atomic mass 26.98154 gram per molar. So electronegativity according to Pauling is 1.5 and density of aluminium is 2.7 gram per centimeter cube at 20 degrees Celsius. Melting point of aluminium is 660.4 degrees Celsius and boiling point is 2467 degrees Celsius. Van der Waals radius is 0.143 nanometer and ionic radius is 0.05 nanometer. It is having 3 isotopes. Artificial isotopes are 16. So properties of aluminium are they are light in weight, corrosion resistance, electrical and thermal conductivity. It is reflectivity is best, and ductility, strength at low temperature, and non-magnetic and odorless. Applications of aluminium are home automation, energy, sport leisure, healthcare, aeronautical, communications, food, security, space and defense, the environment and transportation, etc. Thank you.
Good, Vidya. Completed it. Contents you have collected a lot of many that are there inside it. Way was also good. Just remember one thing is whatever content you put, no, you should know. Right now, no. It's the basic level that we are going through. Again, it's applicable for all, not only you. When we give presentations, no, every content that is in the slide, no, we should know details. Because right now it's not a proper seminar that is going, you're not being questioned on each and every small word that is being used. But further, I'm telling just tips in between for further seminar when we'll be there. When you'll go to tea, seminars are there. Okay, good. Nice one.
Okay, ma'am. Thank you, ma'am.
Next, 41. Patil Prasad. There. No. Next, Patil Rohit.
Yes, ma'am, I'm here.
Yeah.
Sharvari is going to share my PPT.
Okay.
Sharvari, please share.
Yeah, yes, yes.
First slide.
It's visible.
Yes.
Okay.
Good morning, respected ma'am, and all my dear friends. I am Rohit Tatare Patel from SE Electrical, serial number
Just wait
54
1 second.
and roll number 42.
Sharvari, make it a slideshow, no? At the first
Yes,
option
make it a
beside Zoom.
slideshow.
Beside Zoom, the first option you click it. माइनस साइन के साइड में जो ऑप्शन है ना
I
that
am
one.
already doing a slideshow.
Yeah, it's not visible as slideshow right now.
Actually change stop the recording, then log in as general. Present the screen as general, then it will be happen.
Okay.
Because animations are seen beside the slide, they will not be presented otherwise.
Ma'am, I'll share it again.
Yeah.
Yes, ma'am, the animation.
Is it visible now?
Yeah.
Yeah.
Yes. Okay. Good morning, respected ma'am, and all my dear friends. I am Rohit Tatare Patel from SE Electrical, serial number 54 and roll number 42. Now, as all my friends have explained you about topics from material science, so I chose material science as my topic. As the Mangalrian ma'am likes creativity, so I am performing it under the guidance of Dr. Mangalrian ma'am. And the contents in my PPT, that is basic introduction related to material science and career in material science. First slide includes what is material science. Material science is an interdisciplinary field applied. Hello, am I audible, ma'am? Hello,
No. Your PPT
hello.
is not visible.
PPT is not visible. Hello.
Hello, it's visible and audible also. Both are there.
Ma'am, was I audible for the for last couple of minutes?
Yeah, no, between it was not, but it's there now. It's continuing. You can continue.
Okay, ma'am. Now I am not able to see the PPT.
Yeah, because it's visible here.
Ma'am, is it visible?
Yeah, it's visible in front of me. It's there. I don't know whether you will change the slide, then it's changing. Just change, use one option, change the slide. Let's see.
मेरे को दिख नहीं रहा है वो.
No,
मैम
it
जो
is.
पीसी में उनको दिख रहा है, जो मोबाइल पे उनको नहीं दिख रहा है.
No.
Yes, ma'am.
Slide is not
क्योंकि मैं
changing.
दोनों यूज कर रहा हूँ, तो मुझे मोबाइल पे नहीं दिख रहा है, पीसी पे दिख रहा है.
Okay. Sharvari, one more work for
Ma'am,
you again.
yeah.
Yes?
Should I stop sharing and I'll share again?
Yeah. Work for you, Sharvari. Thank you. Do that.
Ma'am, is it visible now?
Yeah, it's
Yes.
visible. Slideshow is not there, but
Yes, ma'am. For the animations, can I share you the PPT as personal message on WhatsApp?
yeah, no problem. But she is doing, na? She has done it, I think so. Just a minute, it will operate.
Okay, ma'am.
Sharvari, done, na?
Yes, ma'am.
Okay, you continue. Right, because it's not there. It's not showing animations. Slideshow is not visible.
Okay, ma'am. What is material science is my first point. Material science is an interdisciplinary field applying the synthesis, characterization, and properties of materials to various areas of science and engineering. Material science is the study of properties of materials. It focuses on factors that make one material different from another. So we will change this, right?
Have you changed Arvari? It is not seen
Ma'am,
again.
I've already changed. It's lagging, I guess.
Maybe it's lagging or it's not getting access because here the option is showing slides option are also seen. It is not going to fourth number slide. It is on third only. Yeah, now it's to fourth.
Hmm. Now, the four types of materials are metals, polymers, ceramics, and composites. Go in next slide. Next number. किया क्या तूने नेक्स्ट स्लाइड
If it's not working, then what we'll do is we'll continue with the next. Then again we'll start with this. Is it
okay
working,
ma'am.
Sharvari? Sharvari, it's working?
She's not there in the meeting. I think
Okay.
some problem has happened with her.
Okay.
The problem with me is that the video sound will not be audible for you. Only mine will be
Okay.
audible by performing it on mobile.
Okay. We'll wait then. Let's see. She comes. We'll continue then with
Okay,
further.
okay
Okay.
ma'am. Then we can continue with next
Yeah.
afterwards.
Patil. Yeah. Patil Viraj.
Patil, ma'am, could I share PPT of Patil Prasad? He's left now. He's not there. I think he has network issue.
No, but he was not there, no?
He was
For
present
the
at
first
tomorrow's
session,
lecture.
he was
Sorry.
there.
Now he's not there. Is he there?
No, ma'am.
Now
He has
he is
Yeah.
network
not.
issue.
There is facing a network issue, ma'am.
Yeah, but if it's not there, how will you on the presentation then? Just let him be there, no? We'll
His
continue.
voice is
Don't worry.
recorded in.
No, don't worry. Let him be there, then we'll see. Patil Yash, Viraj, 44. 43 is also remaining, I think. Shivam Patil. Yeah.
Yes, ma'am. I'm sure.
Shivam, you continue. Yeah, next is your number,
Yes,
43.
ma'am. Arjun will share my PPT.
Okay.
Yes, hello, everyone. My
Just,
name
just
is
Shivam.
Shivam Patel.
Shivam,
Uh,
just a minute. No? Next who is there, be ready so that you don't lag in between. Otherwise, it will not be get completed. Next whose name is there? Viraj is there. Be ready for it, okay? Start, Shivam. Yeah.
Hello, hello.
Am I audible?
Yes, yes, you can continue. Start.
Yes. History of nanotechnologies and nanomachines. Arjun, next slide. Uh, there are three topics today I will cover: nanotechnology terms and definitions, history of nanotechnology, and fundamental concepts. Types. There are three types of. There are three types: nanomaterials, nanorobotics, and nanoelectronics. And last one is overview. Nanotechnology. Nanotechnology is the understanding and control of matter at dimensions of roughly 1 to 100 nanometers, where unique phenomena enable novel applications. Uh, the term nanotechnology was defined by Tokyo University of Science professor Nario Taniguchi in a 1974 paper as follows: nanotechnologies mainly consist of the processing of separation, consolidation, and deformation of materials by one atom or by one molecule. History of nanotechnology. In 1980, the carbon nanotubes. Nanotechnology is ubiquitous, pervasive. It is an emerging field in all areas of science, engineering, and technology. Nanotechnology is seen to have greatest impact in our daily life. It had improved and helped in many field of science. Fundamental concepts, larger to smaller. A materials perspective, a number of physical phenomena become pronounced as the size of the system decreases. These include statistical mechanical effects as well as quantum mechanical effects, simple to complex. A molecular perspective. Modern synthetic chemistry has reached the point where it is possible to prepare small molecules to almost any structure. These methods are used today to manufacture a wide variety of useful chemicals such as pharmaceuticals or commercial polymers. Molecular nanotechnology, a long-term view. Molecular nanotechnology, sometimes called molecular manufacturing, describes engineering nanosystems, nanoscale machines, operating on the molecular scale. Molecular nanotechnology is especially associated with the molecular assembler, a machine that can produce a desired structure or device atom by atom using the principle of mechanosynthesis. Types: nanotechnology is ubiquitous and pervasive. It is an emerging field in all area of science, engineering, and technology. Some are as given: nanomaterial, electronic, nanorobotics, molecular machines, molecular mechanics, nanoengineering, nanobiotechnology, nanofluidics, nanohub, nanometrology, nanoscale networks. Nanomaterials. The nanomaterials field includes subfields which develop or study materials having unique properties arising from their nanoscale dimensions. Interface and colloid science has given rise to many materials which may be useful in nanotechnology, such as carbon nanotubes and other fullerenes. and various nanoparticles and nanorods. Nanomaterials with fast ion transport are related also to nanoionics and nanoelectronics. Nanoscale materials can also be used for bulk applications. Most present commercial applications of nanotechnology are of this flavor. Progress has been made in using these materials for medical applications. See nanomedicine. Nanoscale materials are sometimes used in solar cells, which combats the cost of traditional silicon solar cells. Development of applications incorporation semiconductor nanoparticles to be used in the next generation of products such as display technology, lighting, solar cells, and biological imaging. See quantum dots. C means example. These are some pictures of nanoparticles. Uh, Nanoelectronics. Nanoelectronics is one of the major technologies of nanotechnology. It plays vital role in field of engineering and electronics. Nanoelectronics make use of scientific methods at atomic scale for developing the nanomachines. The main target is to reduce the size, risk factor, and surface areas of the materials and molecules. Machines under nanoelectronic process undergoes the long range of manufacturing steps, each with accurate molecular treatment. The nanotechnology field has been the subject of intense focus, particularly from the viewpoint of the in electronics industry. The commitment is no doubt driven to a large measure by the silicon based. This is hello. Am I audible? Hello.
Yes, yes.
Yes. This is implied in the next generation approach towards manufacture of MEMS, microprocessors, optical switching, and several other electronic components. Nanoelectronics. Nanotechnology is continually playing a vital role to improve the capability of electronic products. The technology also made the devices very light, making the product easy to carry or move, and at the same time, it has reduced the power requirement. Some consumer products which are using nanotechnology, computer hardware, display devices, mobile and communication products, audio products, camera and films. The world market of nanoelectronics is expected to reach 409.6 billion by 2015. These are some pictures of nanoelectronics. Nano-robotics. A nanorobot is a tiny machine designed to perform a specific task or tasks repeatedly and with precision at nanoscale dimensions. That is dimension of a few nanometers or less, where 1 nanometer equal to 10 to 9 meter. Uh, they are nano devices. They are nano devices that will be used for the purpose of maintaining and protecting the human body against pathogens. The joint use of nanoelectronics, photolithography, and new biomaterials provides a possible approach to manufacturing nanorobots for common medical applications, such as for surgical instrumentation, diagnosis, and drug delivery. Potential applications for nanorobotics in medicine include early diagnosis and targeted drug delivery for cancer. These are some pictures of nanorobotics. Overview. Future of nanotechnology, no one knows for sure. History shows that science and technology impact society, but there is no way to predict what new specific, what new scientific discoveries are next, how technology will be used. Thank you.
Good, Shivam. Have you own framed the sentences that you have written in the content?
Yes, ma'am.
All sentences you have framed?
On, no, ma'am. With the help of Google, YouTube.
Yeah, but sentences framed are too many that you have read continuously, okay? Because there lot of contents were there. Contents were good, but totally it was reading. Okay, yeah.
Thank you.
Next,
Ma'am, sorry, ma'am, I had a network issue for a while, Prasad.
yeah. Start,
Uh,
Prasad.
can I can I go with
Yeah,
my
start,
presentation?
start.
Ma'am, Arjun will share my screen.
Yeah.
From class SE Electrical is going to perform activity number 13 on the.
Is it audible?
Yes, Arjun,
Hello?
yes, it is.
Yes, okay,
It is
okay.
audible. Topic liquid dielectric under the guidance of Dr. Mangalin ma'am. The content that I will be going to cover is definition of liquid dielectric, classification of liquid dielectric, properties of liquid dielectric, and applications of liquid dielectric. So the question is, what is a liquid dielectric? It is a dielectric material in liquid state. Its main purpose is to prevent electric discharges. As we know that dielectric material have the property of transmitting electric force without conduction, which means unlike the conduction of heat and unlike the conduction of electric current. This is how the dielectric fluid looks like. This is a dielectric fluid used in an electrical apparatus. Let's see the classification. Liquid dielectrics are classified as transformer oil, synthetic hydrocarbons, chlorinated hydrocarbons. Transformer oil. It is an almost colorless liquid consisting of a mixture of hydrocarbons which include paraffins, isoparaffins, naphthalines, and aromatics. When in service, the liquid in a transformer is subjected to prolonged heating at a high temperature of about 95 degrees Celsius and consequently it undergoes gradual aging process. With time, the oil becomes darker due to the formation of acids and resins for sludge in the liquid. Deposits of sludge on the transformer core, on the coils, and inside the oil ducts reduce circulation of oil, and thus its heat transfer capability gets considerably reduced. Synthetic hydrocarbons. Among synthetic liquid dielectrics, polyolefins are the dielectrics of choice applications in power cables. Over 55% of synthetic hydrocarbons produced worldwide are polyolefins. Most commonly used olefins are polybutyl alkyl aromatic hydrocarbons, example alkyl benzene. Chlorinated hydrocarbons. Two aromatic hydrocarbons, benzene and diphenyl, are chlorinated to produce chlorinated aromatic compounds called ascaryls or simply polychlorinated biphenyl. They possess high fire point. Let's see the properties. Liquid dielectric possesses electrical properties. The electrical properties that are essential in determining the dielectric performance of a liquid dielectric are its insulation resistance offered by dielectrics is generally described as specific insulation resistance rho INS of the DC conductivity kdc. Rho INS is equals to 1 upon kdc. Capacitance per unit volume, resistivity, loss tangent tan delta or its power factor, which is an indication of the power loss under AC voltage application. Let's see the applications. Dielectric liquids are used as electrical insulators in high voltage applications, for example transformers, high voltage cables and high voltage switch gears. Its function is to provide electrical insulation and to serve as a coolant. Breakdown tests are carried out for testing pure liquid as a coolant. Let's see the breakdown test. In the breakdown test, the liquid from the reservoir flows through the distillation column where the ionic impurities are removed. The gases dissolved in the liquid are removed by passing them through the cooling tower and they are pumped out by the vacuum pumps. Then the liquid passes through the filter where the dust particles are removed. The liquid thus purified is then used in the test cell. The vacuum system thus helps to remove the moisture and other gaseous impurities. This is the breakdown system. Let's watch a video on dielectric coolant solution on how it is used and what is the purpose of its application.
I'm Gary Testa, President and CEO of Engineered Fluids, and today we're here with Coriant, and we're going to actually show you how we're going to submerge one of their products in our fluid. So with me right now is 20 liters of our electric-cooled dielectric coolant, and here, if you can see in front of me, is one of the Coriant devices. We've taken the top off, and we're actually going to now pour the coolant on top, after which we're going to turn it on, and I'm going to stick my finger in it to prove to you that it's fully dielectric. So